months here in this semester and get to show you some of what the CIS department is all about. And so without further ado, about a year ago or so, Mrs. Todd presented me with a problem in the CIS department that she'd like me to solve, and she presented me with a solution with some vague guidelines to follow. Basically, when a freshman CIS major joins the CIS department, comes on campus, they're given a place to sit in one of our computer labs over on the other side of the building. And they're given a desk, they're given some stuff to work with, but they're not really given a computer day one. And working with computers is what we do, so they like that. Usually what ends up happening with these students is they'll end up scavenging some alumni's computer, some computer they're not really familiar with. We're not really sure what's on it, what's been done with it, and so it can be a little bit hard to get students started in the lab, which is what we want. We want them to be integrated with the lab and to use it to its full potential. And so with that, sometimes they'll take a long time to get integrated. It'll be tough for them to get used to the space and get work done. And so the solution we've decided to go with is using a thin client network. Now we're all familiar with the typical computer. It's a large tower. It's got your hard drives, your processors, your memory, etc. That's not this. You can see that's a very tiny device. Not much bigger than this. And with the thin client network, basically what you've got is a whole bunch of terminals, a whole bunch of little stations for people to work at. And the thin client little boxes don't have much to them. They've got a little memory, they've got a couple of ports on them and stuff like this. They connect to a switch, as you can see, and they connect to what's in the top. What the top left is a server. Server is going to be a very powerful computer that's going to host the operating systems for all of those thin clients. It's powerful enough to hold all of them, and even dozens more depending on the server. And so what this does is this creates, this is going to save you a lot of, this is used in businesses a lot. This saves them a lot of money, a lot of resources. It's a very simple thing to set up, and it's very easy to replace things. If a thin client breaks, well, you're not really losing anything. Some of you know the pain of losing a hard drive and losing all the data on that. Well, that's not an issue. The server's got tons and tons of hard drives with redundant data so that nothing is lost. One breaks, you pop it out, you put another hard drive in. A thin client breaks, you just replace the box. It's really simple. And each user has their own station, their own login information. It works very, very well. And so with the lab, there's a lot of, with our lab situation, there's a lot of benefits. When this is set up, the students will have a machine to work with day one. It'll take less than 5 minutes for them to set up a username and password and get to work. They'll have a computer to work with, get right into the lab, and have a fully functioning computer to work with. It's not going to be confusing. It's not going to be riddled with someone's old software or something like this. And they can start to get familiarized with the lab sooner and get to be part of the CIS community, which is really important. So when I set out to make this happen, I first had to look at what software was available to me and what was going to make this work. So the first thing I looked at was a software called XenServer, which is a powerful thing called a hypervisor, which is going to store a bunch of virtual machines, which is essentially the same thing this is going to do. And it seemed like things were going to work well, but I discovered that for it to do everything I wanted it to do, I was going to have to pay for some extra software. And I ended up deciding against that, not just because I'm cheap, but also it's in the spirit of the education world to try to do things as cheap as possible. Educators know we try to save money. Well, I'd say we. Educators try to save money in whatever ways we can. And that's very much the spirit of the CIS department as well. We want to reuse, recycle, repurpose everything, and make things better. So I decided to go with an entirely free software called Linux Terminal Server Project. And this was just my boon once I discovered it. It was very easy to work with, had everything I needed. It's totally free, which is wonderful. It's part of the Linux software distribution, which is, they make operating systems totally for free for anyone to use. They may not have everything that Windows has, but they're going to do a lot of the things just as good. And so that's going to work for me. Here's another diagram that kind of shows off, again, same model. You're connected to the internet on one side, your server is holding everything, and you connect it to the terminals on the other side. So I thought that was an easy way of looking at it. So I'll show you what Linux Terminal Server Project looks like. It's not a lot to look at. It's entirely text. You try to move your mouse and nothing happens. It's entirely delightful to work with. But because it's not running a graphical interface, that saves a lot of power, which is nice. And so you enter in commands. You have to know a few commands to learn your way around and stuff like this. I had a lot of online tutorials and online resources to work with, which made my job a little bit easier, but there were a number of hurdles where I had to figure things out. One bug in particular took me six hours to figure out. Very glad I overcame it though, because it all works very well. So here's a picture of my setup at my station in the lab. On the left you can see an Ubuntu client. Ubuntu is the flavor of Linux. Basically that's just the thin client. We've got Ubuntu running on there, and to the right you'll see some other stuff. There's the monitor that's showing my server. Underneath that is a switch which is connecting all of the clients to the server. And underneath the desk, you'll see the 4 little boxes on the left. Well, they're not little. These are in fact what we call thick clients as opposed to thin clients. There's a bit of a difference, but they largely work the same. Thick clients are great because we're repurposing old computers that when they were released were probably top of the line, running the latest and greatest operating system, Windows XP, which is wonderful at the time, but now is not as useful. But thanks to thin client software, we can repurpose these old computers and make them useful again. And so you can plug in any old computer, connect it to the network, and make it work. The bigger one on the right is my server. It has nothing to do with Apple. Somebody just had that sticker on there. And you can see on my desk, they're all connected. And this is just another picture from the operating system itself. You can see you can get on the internet, and there are a number of other programs on the side. You've got an Office sort of suite with a word processor, spreadsheet, a PowerPoint-like kind of thing, and there's a lot of great things you can do with it. So with all that, you can see that students day one will have a lot to work with. They'll get to see something probably new to them for the most part. Most people don't work with Linux. They'll get to see servers and thin clients and virtual machines in action. It'll be a great learning experiment for them. And one of the big things it teaches is that we can reuse old things and make them work. And that's super valuable in the computer world. And so, with that, that's about all I've got to show to you. And I will transition now and let you guys ask me some questions if you like.
So is this something that students are going to be able to take advantage of now? Has this already happened, all of this stuff?
Not quite yet. The final thing for me to do will be to plug the server into the lab network and basically just get that configured. I currently don't have, the network is not currently in a place for me to do that, which is why I haven't. It wasn't really on my end to do that. So once the network is ready, I'll be working with Jeremy Worcester. I probably butchered his last name. I'll be working with him to get this set up, and it will be, it'll be ready next semester at some point.
Could you clarify a little bit more about, in the beginning, you said when a freshman comes, they have nothing, and you said something about they get a computer. So tell us more about that. I don't quite understand what you're saying.
Right. I did neglect to mention, so each CIS major, when they're enrolled in the PC hardware class their first semester, in which they will build a computer their first semester, and they will use that throughout the rest of their years. And so, each student building a computer, there's going to be ones that are left behind when the students graduate, and so that's what I meant when they can scavenge a computer that someone else has built in the past.
Sure.
I neglected to mention that. So it's like the thin clients are mainly for that nice little 2 months period where they don't have anything before they build their computer.
So that thin client is basically one computer running many monitors and keyboards. Is that kind of what you're saying that it does?
Yeah, so it's like this. The big server on the right is running all the computers
Okay.
all the littler computers.
I'm just saying that because I've dealt with something like this before. It was a different company. We've used 2 different ones in my classroom in the past. But they would only run up to 4 computers or 4 users at the same time. So how many could you put on this one? I think, I don't remember how many I counted on the one picture that you had. But like how many, what's your ideal that you want to run?
So how many freshmen do we usually have come in a year? We had 6 this year, is that correct?
Probably 6 to 10.
So we'd probably want as many as 8 or 10 running.
And you guys are probably doing a lot more than my 4th graders were doing. They were just doing PowerPoint and web browsing and maybe watching a few videos here and there. So that you guys could all be doing large things and pulling a lot of things at the same time.
Yeah, for the most part, you're not all gonna want to, be playing games and streaming video, et cetera, but
Okay.
it's perfectly good for, documents and whatnot.
Now, are they sharing a desktop, or are they all distinctly different? Or is it like different machines, or what are we doing with the server? What's the server giving to the machine?
The server is giving to the machine the operating system on which it runs. So the operating system is going to be identical between all of the client machines. They're connecting to the server is saying, okay, here's your operating system that you want, gives it right back to it, and the computer runs it from there. And it's going to share resources with the server as well.
So if I unplug one of those and try to turn it on, what's gonna happen?
If you unplug it and try to turn it on, it will bring up a screen where it tries to boot from the network, and it'll say, I don't know where the network is, and it will be very confused and it won't boot. Or it'll try to boot something else, which might be on the hard drive, depending.
So does each of the little dudes, whatever those things are called, do they each have like their own like section of the server for like saving stuff, or?
Right, yeah. So it's like if you have a Windows machine, you can create multiple accounts,
Yeah.
multiple users and passwords. That's kind of how it separates, is it's by user. So I have on here Ben 1, Ben 2, Ben 3, Ben 4, and each of them has their own files. They're stored separately, and so they can't mess with each other's files.
So you see something different than what other people see, we can actually see yours work or this person. So this company that you found that will offer the free service, like, is that the server, I'm sorry, I'm not.
Yeah.
So, can you describe
basically,
your role with it?
describe what?
Go ahead, what were you going to say?
So Linux is a bunch of independent people who develop an operating system, and they develop a whole bunch of different versions of this operating system, this flavor being Ubuntu. You might have heard that before. And so they all do this for free. It's distributed on the internet. Anybody can download and use this software completely free and without any licensing issues. And so a bunch of different people develop a bunch of different things, all under the name Linux.
That makes sense.
So are they pretty reputable then?
Yeah, they're among a lot of computer people. They're pretty reputable for making good stuff, and it's free, which is just wonderful.
And you use the word flavor, which I think is very interesting. What does that mean? Flavor is like ice cream.
Flavor is like ice cream. So to talk about that, I kind of have to talk about how an operating system works. So an operating system obviously is what runs on your computer. It's what runs your applications and whatnot. It's what you interact with to make the hardware do all of its electrical things. So that's the operating system, like Windows, like Mac OS, etc. And so Linux is like, they call it a kernel. Linux is like a certain set of code that is the basis for all Linux operating systems, all the different Linux flavors. So you've got a base that is Linux. And then on top of that, people have added other things like graphical interfaces, like programs, like the ways we interact with it. That makes it look pretty. And so they add all these things on top of it, and they call it Ubuntu Linux, or they call it Debian Linux, or they call it Red Hat or Fedora, etc. There's hundreds of these things. And so these are the flavors of Linux that are added on top of a little kernel that is still Linux. It's still running basically the same stuff, but it has its own added benefits, depending on which flavor you go with, or we call them distributions or flavors.
I know, it's like
How-
chocolate sauce on top of the ice cream.
About-
Yeah, you have to use food.
Some of them have sprinkles.
About how long did you have to work on this project?
The project took a little less than 40 hours for me to put together. So a lot of that was troubleshooting, figuring out what did what, figuring out the best way to do each thing, and banging my head against the wall when it refused to work, et cetera, et cetera.
Ben, what is something that you've learned from this project that you feel is really going to be useful for you in your career? When you work for a company or you're helping
Yeah, for sure.
a mission organization or something?
One of the big things is that almost no piece of hardware is truly unusable, and that a lot of things can be repurposed and reused if you have the determination to figure it out. I've learned that it's a lot based on how much effort that you're willing to put into it is the product that you're going to get. That seems fairly obvious, but this kind of made it clear that the quality of what you're going to get is very determined by how much effort you put in and how much you're willing to work on it.
Is a senior project something that every student should go through?
Most certainly. It gives students a chance to do something that is practical rather than just reading in a book about something. It's been a great experience for me. I'm very happy to see this work, and I'll be very happy to see it implemented in the lab next semester. Of course, I won't see the freshmen using it because I'll be graduating, but I think it's exciting to see something I'm working on, something I'm learning about actually used. I think that's super important for senior projects. And also getting to talk about it is really great, because sometimes we don't get to talk about what we do in our majors, and we don't get to share that with people, and so I think that's really great.
Could you go back to this first picture of your slides, please? First picture you showed, that little machine that's sitting there in the first picture is a very tiny one, but when we look at the ones you have connected, it looks more like a regular computer.
Right.
And you talked about the difference there, but could you tell us why yours look like a regular computer and why this one looks like a little tiny box?
Yeah, so thin client versus thick client.
Do
Thin
we
clients,
have
of
in,
course.
do we have thin clients?
Do we have thin clients? Yes. I didn't get a picture, but I have a thin client. And it does do the same thing, and it works the same way. The difference mainly lies in what components are in it and how old it is. I mean, thick clients don't necessarily have to be old, but so a thick client will have its own hard drive. A thin client will not have a hard drive. It has no need for a hard drive. It stores all its data and retrieves all its data from the server. They're both going to have memory, which is of course important for a computer. The thin client will still have ports. You can plug in mouse, plug in keyboard, plug in a USB flash drive. A lot of them won't have CD-ROMs or anything. You won't use CDs generally with them. So yeah, the difference just generally lies on what's in it.
So will any of them be buying a thin client?
Will anyone be buying a thin client? Not unless you work for a business that's using them, probably. It's not generally a home-based sort of thing. You could certainly implement one of these in your home. If you have a nice server lying around, some old computers, you could certainly do that if you want. Yeah.
Is this something that really benefits large companies that have like hundreds of employees that are needing to work?
For sure, for
Do
sure.
they utilize this a lot?
Yeah, businesses today love to have things centralized and like away from the person's desk, because user error is an issue with people, and sometimes a user can do something unknowingly that messes things up, and they'll need to have that corrected. And the less components you give to an individual user, I mean, you think about it, with 100 people working for you, one of them is bound to do something stupid. It just happens. You know, there's just a margin for error. People sometimes do stupid things. That's not that they're stupid people. It's just that they can do something wrong. And so, like I said, everything's replaceable pretty much, aside from a couple internal components on the server. And even then, if the hard drive fails, you replace the hard drive. They have what's called RAID, which is an array of redundant array of independent drives. Basically what it means is if one hard drive fails, another one's going to pick up the slack. The data is stored somewhere else. The thin clients are replaceable. It's very, very well suited for a big business. Yeah.
How does the server that you created compare and contrast with the one that we have here at the university that we signed into as students?
To the servers that you sign into?
Yeah.
Um,
If I logged into a computer at the library, right, I like log in, is that kind of similar to what you have going on here?
It is similar in that you need to be connected to the network in order to sign into your account, because the account information is stored on the server. And you've got a drive, you put information into your drive on one computer, you go to another computer, it's there magically. Well, it's stored on the server. You've got server drives. How comparable is the server? I don't know what kind of servers they're running. I imagine they're pretty powerful if they're being used on the campus scale. There's probably a bunch of them. Like we said, we like redundancy. And like if something breaks, we want to have another one right there to have it ready. Because if somebody's computer goes out or if the internet goes out, you know how quickly people start to panic. Very, very quickly. Did that answer your question? Yeah.
So in essence, then, this is, for layman's terms, for those of us who are not up to IT speak, this is basically one computer running multiple monitors.
Sort of.
Okay.
Yeah, it does run multiple monitors, but so with this computer, this is a monitor, that's a monitor for this computer. But this is the same computer. It's just going on two different screens.
But yes, so basically layman's
Yeah,
terms,
yeah.
one computer, multiple monitors,
Mhm.
where multiple people are able to do things with their own login,
Right.
but still saved to a central
Yeah.
location.
Mhm.
Okay, just trying to understand.
Yeah.
But you still have to have that little guy.
Yeah, you have to have something. You can't just have a monitor.
Yeah.
Right.
Monitor.
And they're all connected through wires and cords, correct? Nothing is like a Wi-Fi connectivity or?
You can, I believe they do make thin clients that do wireless. Generally, we don't like wireless because sometimes, there's interference or it can be unreliable. Sometimes the Wi-Fi is just down. We don't know what's wrong with the Wi-Fi. Maybe there's, any number of things. A microwave can shut down a Wi-Fi network because they're on the same frequency, It can do all sorts of weird things. And so we like to have cables. We like to have at least one cable.
Right.
Do you think this is something that could benefit, like, for example, a higher educational institution like HLG where all the faculty were to have a big client or a big client?
Right.
And run off, instead of each of us having our own unit, does it make sense?
Mm-hmm. Yeah, I mean, you would see a lot of the same things. I don't know that it would drastically change how you're currently doing it.
Would it save money?
Would it save money? I haven't thought about this truly.
Sorry, it was.
You're right.
We're all about saving money.
For sure.
Education. Right.
I mean, if you had a faculty who didn't need anything special, the thin client would be nice because, if a faculty is only using Microsoft Word, then, that doesn't take up anything. That doesn't take up any resources, and so you could use a smaller client with them. Whereas if another faculty is in communications and they're doing presentation stuff, all this graphical stuff that takes up plenty of processing power, you get them a nicer unit. It still is connected to the network, still does that sort of thing, but it's
You still have to tailor it to the needs.
Mhm. Yeah, you could definitely do a lot of customized things and save some money here and there. All right. Any final questions?
I don't have questions, and I don't want to take away from your presentation, but a couple of things to help clarify a couple of the questions. To you, these are like 4 different machines, all on that same server, so everything you send back and forth has to go across the network. So they're sending their desktop, it's treated like 4 different machines, not just sharing monitors. I think he's trying to say that to you, but I think there's a communication gap here.
No,
So
I
it's not
understand.
exactly the
Right.
same kind of system you had in your school. Ben, to address your question, the difference in servers, he told you a lot about the power. The idea of how you do it, like in the library, if you were to unplug the network cable from the one in the library, you could still do quite a bit of work on that machine. Word would still come up. You could actually function, you just couldn't save it on the network. You couldn't get to the internet, but the machine itself would work. A thin client, you unplug it, nothing works. No operating system, no Word, no anything. The whole thing is gone. So those thick clients over there have some kind of processing, and he did say that. And then to help you understand what it saved money, he did a pretty good job with that question. Yes, in a sense, think of a hospital where a lot of people do a lot of the same kinds of tasks. Those would be really helpful. So if the computer crashes, you just walk in, take that thin client out, put that one in, and everything they had is ready to go, boom. But he did say, like, for certain tasks, you need that processing power right there to help it. Like if you're doing graphics, you need all the extra oomph in that machine, and those things don't have all the extra oomph. And if they did, it would have to go across the network, and it would tie up the traveling time. So we don't use them necessarily here because we don't have great bandwidth all over the campus. So while it might save money, it wouldn't save us on network speed, so they probably don't do it that way.
So like if you had a bunch of workers, say a mass amount of workers for Sprint, and they're all sitting there doing similar things in their little cubes.
Little call centers or whatever,
Right,
yeah.
then that would be sufficient, but
Yeah.
because we each have such
And-
unique needs and.
Right, we are a little different
A little
than,
different.
yeah, but Blessing does use them, so think about all the offices that are around and they're doing just standard input. So they use them and then they just walk in, pull one out, put one in, boom, you're back up and ready to go. That's how fast the change out is. And so sometimes that works for us, sometimes that doesn't. We're doing more with virtual machines than we are with thin clients right now on campus.
Right, so thank you so much for asking lots of questions. I was really glad to talk with you guys. And again, thanks so much for coming out and seeing what I've done and getting affiliated with some confusing but very interesting computer things. So I assume you can just leave your papers and pens, and we'll take all of that. And
Did you
have
want-
a wonderful evening. Thanks so much again.
Did
for
you
coming.
want to invite them down the hall?
Oh, yes, right. If you'd like to see everything in action, I've got everything set up in the lab. It's a little cramped, but there's plenty of room for us to come in and see things if you want to go and walk with me and see things. See them, you know what I mean?
He'd like to walk you down the hall and let
Yes.
you take a look,
Yes.
is what he's saying.
We're going.
All right. All right, well, thank you. If you'll write in some comments, and we'll take care of those. Thanks for your time. It's important for us to be able to give our students this kind of feedback, so appreciate it.